Kinda, sorta. What's the rule of thumb for adding and subtracting fractions that need to be true always? They have to have a what? Yeah. A common denominator. So which means the bottom number must be the same. So it says example 1, reduce each fraction. Do not write your answers as mixed numbers. That's the biggest thing I'm trying to get out between the middle school and the high school. Don't write your answers as mixed numbers. If you see me underline something, that's the equivalent of highlighting it. That means it's important. No more mixed numbers. You're going to see mixed numbers here and there on ACTs, but when it comes to Algebra 1, we do not do that. We leave it as improper fractions and we work on it from there. And do not write your answers as decimals. So, not mixed numbers, not decimals. Reading your directions is fundamental. So if I'm looking at A, I have 4 over 8. 4 over 8. My question to you is this. Is 4 a factor of 4? Yes or no? Yes, because what multiplies to 4 to get 4? 1. Is 4 a factor of 8? Because what multiplies to 4 to get 8? 2. So can this fraction be reduced by 4 at the top and the bottom? Yes. So what's 4 divided by 4? And then what is 8 divided by 4? So it should be what when it's reduced? 1/2. Any questions on what I just did there? Yes, no? Does it make sense? The goal is to look for a common factor. Does that make sense? So I'm going to put an asterisk up here, and I'm going to write this small note. Look for a common factor, if possible, because sometimes you can't simplify at all. Common means that they share it. So my next fraction is 4 over 6. What's a common factor between 4 and 6? 2. So what's 4 divided by 2? And what's 6 divided by 2? Are there any more common factors between 2 and 3? No. Then that's it.
Warm body count at this time. Put it on your door. How many warm bodies do you have in your room?
Sorry, y'all. I had to do that real quick. I did it while y'all were doing bell work because I'm not missing any kids. So that's a win for me. I don't know anybody else. So, looking at 5 and 15. Is there a common factor between 5 and 15? What is it? 5. Because what multiplies to 5 to get 5? 1, right? And what multiplies to 5 to get 15? So what would this fraction be? 1 over 3, right? Or 1/3. Is there any other factors between 1 and 3? So that's the answer. Is this making sense for everybody? Everybody good? All right, looking at D right here. 15 over 5. Is there a common factor between 15 and 5? What is it? Because isn't it the same thing as this? But it's just flipped. So what should this be? 3 over, which simplifies into 3. Because does 1 change anything when you're dividing by it? Does it change anything when you're multiplying by it? So my answer should be what? Now, I'm going to show you how to do this in your calculator as well. But doing it by hand, is it pretty simple? Yeah. So, looking at even letter A. This is where you grab your calculator. We already cleared it out, so you're all good. You're going to type in 4, the divide button, which is right here, divided by 8. Everybody right here? Then hit enter. Isn't 0.5 the same as 1/2? But they told us do not write it as a what? We need it as a fraction. So you're going to click Math, which is right underneath Alpha, which is the green button. It says Math, M-A-T-H. And then you're going to click the number 1. And you see how it says Answer Change to Fraction? Then hit Enter. And what did it just give you? A fraction. It gave you 1/2. So did we get it right? There we go. Any questions there? Does anybody need me to walk through this again? I'll do it one more time. Look at number B. Well, letter B. Excuse me, number B. I told you my mind is still on summer. We're getting back. So what am I typing in? 4 divided by 6, and then enter, right? They gave me 0.6 repeating. Look at that repeating number. Is that rational or irrational? Which one? Rational, because irrationals don't repeat and they don't terminate. But is 6 repeating all the way? Just because it turned into a 7 doesn't mean anything. Your calculator rounds up that last number, because if it's 5 or higher, it goes up, right? So, what do I need to click from here? What button is next? Math, then 1, and then enter again. Did it give me 2/3? So are both ways available to be done? Are we all good? We feeling a little bit confident? All right. Let's look at number 2, our example. It says when adding and subtracting fractions, find the least common denominator, or the LCD. I would write that next to that, because most times we don't say least common denominator, we use this acronym instead. Write equivalent fractions with the least common denominator. What does equivalent mean? Equal, the same. It has to have the same, right? And then add or subtract the numerators, which is the top number. Leave the denominator. And then most importantly, simplify if possible. That's what we just did up top. This was all simplifying at the beginning. Reduce means simplify. So if you don't know, we can write that as well. And one thing you'll know about me as a teacher is I add a lot of these extra notes. And that's because when you look at your notes, it should be a detailed description of what you're doing. This is called active note taking, because if I'm writing it, it's important. So should you be writing it? Sometimes I won't write what I'm saying, but it resonates with you. Should you write it? Yeah. I'm not going to judge you, because the only two people looking at your paper is me and you. Does that make sense? Okay. So, were people still writing that? Hang on real quick. Let me know when you're good. Ain't no rushing up in here. We take our time, because I want you to pass the first time. Now I got to switch this bracelet to the other hand. It's hard to write. It's a pencil, if you didn't notice. I'll show you in the camera. How math teacher is that to have a pencil bracelet? All right, everybody good writing this? Okay, that's me freezing the screen. So when I unfreeze it, it's going to be on a different piece of the paper. So the directions say perform each operation, meaning add or subtract. Reduce each fraction if possible. And then do not write your answers as mixed numbers, and do not write them as decimals. That's the biggest 2 rules they gave us. So looking at letter A, what are my 2 denominators? 3 and 7. So I have to look for a least common denominator between 3 and 7. The best way to do this is think of multiples. When you have a multiple, what are multiples of 2? 2, 4, 6, 8, because you're multiplying 1, you're multiplying 1, 2, 3, 4, 5, 6, all those whole numbers by 2, right? So we need to look at the multiples of 3 and 7, right? Looking at this, is that easy to do just looking at them as is? Not to most people, right? So the quickest way to get a least common denominator between 2 prime numbers is to multiply them to each other. Does that make sense? Because nothing that I list up through is going to match. So write this out to the side for me. Put a 3 and put a 7. What's the very first multiple of 3? Just 3, because what's 3 times 1? This is something you can also type in your calculator if you're a little bit insecure about it. You see how I just typed it in? Just keep going. So 3 times, what number would come next? 2, which is what? What comes next? Which is? And then? Which is? We can keep going, right? So what's 3 times 5? 3 times 6? Make sure you're typing in along with me if you're unsure about it, okay? Because remember, I'm not typing it in on your quiz, and I don't do tutorials like this on your quiz. I sit over here quietly, Ms. Davis sits over there quietly unless she's reading aloud, and even then, there's headphones for that now. So she's going to be chilling. So if you see me typing, should you be typing? Yes, because that's building your confidence. This is a new calculator for you. You haven't really seen these or dealt with these like this. So type it in, get comfortable. Type it in, get comfortable. What would come next? Which is? What's the first factor of 7? What's next? And after that? So was our assumption correct? So what's the least common denominator between these two? So I know already I need to take 1/3 and change it into something that's over 21. What did I have to multiply to 3 to get 21? 7. So what I do to the bottom, I also have to do to the what? So it's 1 times 7. So looking at this one, 3 over 7 has to change into something over 21. What multiplied to 7 to get 21? And what do I do to the bottom? I have to do to the... So what's 3 times 3? So my new thing is 7 over 21 plus 9 over 21. Because we add or subtract the top, right? So what's 7 plus 9? And the numerator should stay the same, correct? Now can I check 16 over 21 in my calculator to see if it simplifies? Yeah, so what would I type in? 16 divided by 21. So type this in along with us, that way you know how to simplify. Hit enter, right? And then what do I do from there? Math 1. And then enter. Did that simplify any? Or did it give me the exact same thing back? Then that's the answer. Ain't nothing else I can do. Any questions there? Everybody good? Make sense? All right, let's look at B. What are my denominators I'm working with? 3 and 10. Am I dealing with one of them that's prime? Which one is prime, 3 or 10? 3, right? Because there's nothing else I can multiply to get 3 besides 1 in itself. So what should I do between these two numbers to get my least common denominator? You can do that if you'd like, but do we want to do that all the time? So what can I do between these two numbers? Multiply them. So what would be my least common denominator between these two? What is it? 30, because it's 3 times 10. So I have to change 1/3 into something over 30. So what multiplies to 3 to get 30? 10. So what do I do to the top? I have to do to the... So what's 1 times 10? And then we have 3 over 10, right? Has changed into something over 30. What multiplied to 10 to get 30? What multiplied to 10 to get 30? 3. So what do I do to the bottom? I have to do to the... So what's 3 times 3? So how would I rewrite this? Which gets me over. Now the question here is there any factors between 1 and 30? So is this fully simplified? Yep. But if you're unsure, can you type it into the calculator? Absolutely. Any questions there? Is everybody confident so far? We feeling good? Okay, let's look at C. Reference your examples always, okay? What are my two denominators? So, do I need to do anything different than I did to letter B? Because am I dealing with the same denominators? Yeah. So, looking here, what's my least common denominator? 30. So, 7 over 10 has changed into something over 30. What multiplies to 10 to get 30? What was that? What multiplies to 10 to get 30? 3. So what's happening to the bottom must also happen to the what? So what's 7 times 3? 21. What about the bottom? You tell me. Y'all agree? Because it multiplies to 3 to get 30. So, what should be my new numerator? Because what's 10 times 2? So how would I rewrite this? Which equals? Over what, sorry? Because should the denominator change? Or is there any more factors between 1 and 30 besides 1? So is this fully simplified? Any questions there? Any at all? Alright, looking at D. What are my two denominators? Are either one of these prime? Because what can multiply to get 4? 1 and what multiplies to 1 to get 4? What multiplies to 1 to get 4? 4. But what else multiplies to get 4? 2 times 2. That makes it not prime because there's something other than 1 that could be multiplied. Does that make sense? And 10's not prime because it's 1 times 10 and then what else? 5 times 2. That's what makes it not prime. Does that make sense? Give me an example of a prime number. 3. Because 1 times 3, right? Give me an example of another one. 1 times 1, which makes 1. What about you, Annabelle? 7. Because 1 times 7. The same thing with 13, right? 1 times 13. That's all you got. What's another one? Got y'all thinking hard today. What about Annabelle? Because 1 times 9, what did you say? 3 times 3. Prime, 1 times 5, because there's no other number that multiplies to get 5. Does that make sense? Prime numbers mean what whole numbers multiply to get this number. If it's 1 in itself, it's prime. So 1, 3, 5, 7, 13, those kind of numbers, there's nothing else that multiplies to get them. Does that make sense? So you just have to know the factors. Don't worry. I'm going to help you with that. That's the whole point of this section, okay? So, looking at 4 and 10, we might need to list these ones out, right? Let's look at these. So, let's do 10 first. Well, technically, let's do 4. What are the factors of 4? 4. Well, multiples of 4, sorry. 8, 12, 16, 20. Let's stop there. What are the multiples of 10? Do you see something that's common between those two? So what's my least common denominator? So I'm trying to get them both to have a denominator of what? 20. So we write in the top one, I have 9 over 10. What needs to multiply to both? 2. So 18 over 20. What should be my next one?
16.
So we have 8 over 4, which equals to, that should be 20 down there. So what multiplies to 4 to get 20? You know how it's easy to do it? Count. 1, 2, 3, 4, 5. So 4 times what gets me 20? 5. So, what am I multiplying? What's 8 times 5? So how would I rewrite this? What needs to be written first? Look at your previous examples. What would be written first? 18 over 18 over, what's the denominator? 20. What needs to go behind it? A addition sign, a plus sign. Then what needs to go behind that? So should the denominator change? No. So what do I need to do with the top part? Add them. So what am I typing into the calculator? 18 plus 40. Get that typed in for me. And what does that get you? Do I need to check to see if this simplifies? So how do I do that? So what am I typing in? I'm checking to see if this simplifies. So what needs to be typed in? But before that, 58. What was it? Over 20, which is divide 20. Then you could do either way. They both work. Did that change? So did that simplify? Sure did. So what's my final answer? I see some people getting caught up on this step to this step. Am I correct here? Some people getting stuck from here to here? Let's do some color coding real quick. So, this goes with this, which makes this. Does that make sense? This goes with this to make this. This goes with this to make this. But the sign in the middle does not change at all. It stays the same. This is why I said having highlighters and colored pencils or something is important, because color coding is everything in math if you're wanting to see step by step by step. Does that make sense? So, the same thing goes for this down here. This one turned into this one, which made this become that. That's what makes them the same. These are equivalent fractions, because if I were to type in 18 divided by 20, type that into your calculator for me, please, and thank you. Don't hit the fraction button. Just type in 18 divided by 20. Did you get 0.9? Type in 9 divided by 10. Did you also get 0.9? Aren't those the same? Equivalent fractions means that you're not changing the actual numerical answer of the fraction. You're just changing its appearance. That's like if somebody comes in and they come in with a new haircut. Did that change who that person is? No. Or did they just change their appearance? So you have to treat fractions the exact same way. They got a haircut. In this case, they got extensions, because 9 over 10 is smaller than 18 over 20. Does that make sense? Those are bigger numbers than that. So, from here to here, haircut. From there to there, extensions. They add a little bit extra for it to make sense. Any questions there? So tomorrow we know probably have some kind of highlighter, some kind of coloring tool, right? That way we can color code with this Lipsey. And some people like to color code exactly with me. You do not have to do that. Use any colors that you have. That's perfectly fine. Just make sure your notes are differentiated, okay? So this one went with this one to create this one. And the plus sign stayed the same. Everybody good? So those are the actual examples that we had here, okay? These four. These four are going to help you when you flip that page over. So go on and flip that page for me. I'm going to have you do a few examples for me before you leave, okay? And you're going to bring them up to me, and I'm going to give you a daily grade. So, I want you to do number 1. Circle these. I want you to do number 1. And I want you to do number 8. And number 4. And then for this bottom one, I want you to do number 9 and number 11. So we have 1, 4, 8, 9, and 11. Go on and start working on those. Bring it up to me when you're finished, okay? Yes. Not in the last 10 minutes. Yes, sir. Huh? Oh, finish up all of them if you can and bring it to me. That way I can grade it more evenly. So work on these problems for me. You got to, I call time, okay? I'm going to try to keep it where you're able to pack up and go. Make sure you follow the directions. No mixed numbers, no decimals. Look back at previous examples.